Today's lesson, we're going to talk about correlations. Linear correlations, we're going to use the letter R. Also called the correlation coefficient is the way to numerically measure the strings and the directions of the linear relationship between two variables. Okay. So correlation is usually between -1 to +1. And you can tell here if it's a -1 is strong, start from the weak 0, right? And if we go to +1, it will be strong +1. So if it's going from 1, between 1 and 0, if it's close to 0, we're going to say weak positive. Or if we go close to 1, it will be strong positive. Same thing with the negative, right? Strong, getting close to -1 will be strong negative. Getting close to 0 will be weak negative. So using the example, let me see if we can analyze the regressions. So if we're looking at the first one, we have linear, right? This is the linear regressions of 0.94. This is close to +1, so this is going to be have a strong positive linear relationship, right? That's what you could say. This one is -0.15. -0.15 is more close to 0 than 1. So this one is the very weak negative linear relationship, right? This one is -0.88, which is close to -1. So you will say this is going to be strong negative linear relationship. Negative relationship will give you the decreasing slope, right? Decreasing. This one is going to be 0.58. So you could say this one have a moderate positive relationship. So then next example, we're going to look at and see if we can find the regressions from the data. Example 2, we're going to see if we can find the correlations. And we've seen this data before when we were looking at linear regressions, right? When we are looking at linear regressions with the times per week, your weight was going down, right? We've seen this one before. We found the linear regressions. And in order to find the linear regressions, we found all this value before, summation of xy, summations of x squared, summations of y squared before. So that's what we're going to use it. If you go back to that previous section, you can see summation of x was 15, summation of x squared was 55, summation of y was 1,147, summation of y squared was 219,325. Summation of x times y was 2,836. So when we replace all those values into the formula, right? This is the formula. This is what we get. And when we replace those numbers in a calculator, we'll get close to -0.935. Right. So what does that mean? This is going to be strong negative linear relationship. Remember this one was linear, right? So the B is saying this is the strong linear, negative linear relationship.